Download this code from codegive.com, link in the description below. Understanding test cycles, a comprehensive guide with code examples. Test cycles are fundamental to software quality assurance. They represent a structured execution of test cases to ensure that a software application meets its intended functionality, performance, and quality standards. Understanding test cycles is crucial for anyone involved in software development, from developers and testers to project managers. This guide will provide a detailed exploration of test cycles, including their purpose, benefits, structure, different phases, variations, and practical code examples to illustrate their application. What is a test cycle? A test cycle is a series of testing activities performed to validate a software release or a specific set of features. It's a structured, repeatable process that involves planning, preparation, execution, and analysis of test results. Each cycle is designed to verify the software's behavior against predefined requirements and identify any defects or deviations. Why are test cycles important? Test cycles provide several significant benefits. Improved software quality. They rigorously evaluate the software, uncovering defects and ensuring it meets the specified quality standards. Reduced risks. Early detection of bugs reduces the risk of releasing faulty software, which can lead to user dissatisfaction, financial losses, and reputational damage. Increased confidence. A well-executed test cycle builds confidence in the software's reliability and stability before its release. Better communication. Test cycles provide a clear and structured framework for communication between developers, testers, and other stakeholders. Cost effectiveness. Identifying and fixing bugs early in the development cycle is significantly cheaper than addressing them after release. Traceability. Test cycles provide traceability between requirements, test cases, and defects, allowing for a clear understanding of the software's testing coverage. Data-driven decisions. The results of test cycles provide valuable data that can be used to make informed decisions about software release readiness. Phases of a test cycle. A typical test cycle consists of the following phases. 1. Test planning. Objective. Define the scope, objectives, and resources for the test cycle. Activities. Define the testing goals, example verifying specific features, performance testing, security testing. Identify the features and modules to be tested. Determine the testing environment and infrastructure. Allocate resources, testers, equipment, tools. Create a test plan document outlining the testing strategy, schedule, and roles and responsibilities. Risk assessment. Identify potential risks that could impact the testing process. Establish entry and exit criteria. Define clear conditions for starting and completing the test cycle. Choose testing type. Determine what types of testing are relevant, e.g. functional, regression, performance, security. Deliverables. Test plan document, test schedule, resource allocation plan. 2. Test design. Objective. Develop test cases and test data based on the requirements and specifications. Activities. Analyze requirements documents, user stories, and design specifications. Design test cases to cover all functional and non-functional aspects of the software. Create test data sets to execute the test cases. Define test procedures and expected results. Prioritize test cases based on risk and importance. Deliverables. Test cases, test data, test procedures. 3. Test environment setup asterisk. Asterisk objective asterisk configure the test environment to accurately simulate the production environment. Asterisk activities asterisk. Asterisk install and configure the required hardware and software. Asterisk create test databases and populate them with test data. Asterisk configure network settings and security protocols. Asterisk ensure the test environment is stable and accessible to the testing team. Asterisk deliverables asterisk functional test environment. This should match production as closely as possible. 4. Test execution asterisk. Asterisk objective asterisk execute the test cases and record the results. Asterisk activities asterisk. Asterisk execute the test cases according to the defined test procedures. Asterisk record the actual results of each test case. Asterisk identify and document any defects or deviations from the expected results. Asterisk retest fixed defects to verify the fixes. Asterisk track test execution progress. Asterisk deliverables asterisk test execution results, defect reports. 5. Defect reporting and tracking asterisk. Asterisk objective asterisk document and manage defects identified during test execution. Asterisk activities asterisk. Asterisk log defects in a defect tracking system, example Jira, Bugzilla, Azure DevOps. Asterisk provide detailed descriptions of the defects, including steps to reproduce them. Asterisk assign defects to developers for fixing. Asterisk track the status of defects throughout their life cycle, example open, assigned, fixed, closed. Asterisk deliverables asterisk defect reports, defect tracking system. 6. Test closure asterisk. Asterisk objective asterisk summarize the test cycle activities and results. Asterisk activities asterisk. Asterisk prepare a test summary report outlining the test coverage, defect statistics, and overall assessment of the software quality. Asterisk analyze the test results and identify areas for improvement in the testing process. Asterisk obtain sign-off from stakeholders to indicate that the testing is complete and the software is ready for release. Asterisk archive test artifacts, test plans, test cases, test data, test results, defect reports. Asterisk deliverables asterisk test summary report, sign-off documents. Variations of test cycles. While the basic structure remains the same, test cycles can be adapted to fit different project needs and development methodologies. Here are some common variations. Asterisk regression test cycle asterisk focuses on verifying that existing functionality remains intact after code changes, example bug fixes, new features. This is often run automatically after each build or deployment to a staging environment. Asterisk integration test cycle asterisk tests the interaction between different modules or components of the software. Asterisk system test cycle asterisk tests the entire software system as a whole, ensuring that all components work together correctly. Asterisk acceptance test cycle asterisk performed by end users or stakeholders to verify that the software meets their requirements and is fit for its intended purpose. This usually marks the final test before release. Asterisk security test cycle asterisk dedicated to finding vulnerabilities and security flaws within the system. Code examples illustrating test cycles, conceptual. It's important to understand that test cycles don't directly involve writing code. They are a process around writing and executing tests. However, we can illustrate how test-driven development, TDD, integrates into a test cycle. TDD is a development practice where you write tests before writing the code itself. This leads to more testable and robust code. Let's use a simple example in Python. Explanation asterisk. *ptest*. This is a popular Python testing framework. It makes it easy to write and run tests. *assert statements*. These are used to check if the expected result matches the actual result. *test_add_positive_numbers, etc. These are individual test functions. ptest automatically discovers and runs functions that start with test_. *TDD and test cycles*. This example shows how TDD fits within a test cycle. You plan the tests, write the tests first, see them fail, then write the code to make them pass. More complex example, illustrating regression testing. Imagine you have a more complex function that calculates the area of a rectangle. Explanation *. One initial function and tests *. The initial code and tests verify the basic functionality of calculating the rectangle area. 2. Bug discovery *. A bug is found, the function doesn't handle float inputs correctly, it just truncates them and gives the wrong answer. 3. Regression test cycle *. The developer fixes the function to handle float inputs by returning -1 to indicate an error. Crucially, a new test case, test_calculate_area_float_returns_error, is added to verify the fix for the float input issue. All original tests are also rerun to ensure that the fix didn't break any existing functionality. Regression testing, this is the core of a regression test cycle. We want to make sure that fixing one bug doesn't accidentally introduce new ones. Tools for test cycle management. Several tools are available to help manage test cycles efficiently. Test management tools. These tools, example TestRail, Zephyr, X-Ray, provide features for test planning, test case management, test execution, defect tracking, and reporting. Defect tracking systems. Tools like Jira, Bugzilla, and Azure DevOps are used to track and manage defects throughout their life cycle. Automation testing tools. Selenium, JUnit, TestNG, ptest, as shown in the examples, and other tools are used to automate test execution, reducing manual effort and increasing test coverage. CI/CD pipelines. Continuous integration/continuous delivery pipelines automate the build, test, and deployment process, enabling faster feedback loops and more frequent releases. Best practices for test cycles. Start testing early. Begin testing as early as possible in the development cycle, example through TDD or shift left testing. Define clear test objectives. Clearly define the goals and scope of each test cycle. Prioritize test cases. Focus on testing the most critical and high-risk areas of the software first. Automate where possible. Automate repetitive and time-consuming tests to improve efficiency. Maintain test data. Keep test data organized and up to date. Track test execution progress. Monitor test execution progress and identify any bottlenecks or issues. Analyze test results. Carefully analyze test results to identify defects and areas for improvement. Document everything. Thoroughly document all aspects of the test cycle, including test plans, test cases, test results, and defect reports. Communicate effectively. Maintain open communication between developers, testers, and other stakeholders. Continuously improve. Regularly review and improve the testing process to enhance its effectiveness. Conclusion. Test cycles are essential for ensuring the quality, reliability, and stability of software applications. By following a structured approach to testing, organizations can identify and fix defects early, reduce risks, and deliver high-quality software that meets the needs of their users. Understanding the different phases of a test cycle, the variations that can be applied, and the tools that can be used to manage them effectively is crucial for anyone involved in software development. The code examples provided, while conceptual, illustrate how testing is integrated into the software development process and highlight the importance of regression testing. By adhering to best practices, teams can optimize their test cycles and achieve significant improvements in software quality. Remember that test cycles are not just about finding bugs, they are about building confidence in the software and ensuring that it meets the expectations of its users.